Okay, what we're going to do now is go back and look at the examples we've had so far for hypothesis testing, but do one of these alternative approaches and see whether that saves time, whether you prefer it or not. So we're going to look back first of all at example number 1, which I'm summarising here. You've got the full question typed in front of you, hopefully in your notes. But we had a population. What was W? Can anybody tell me what was W in example 1?
Distributed normally 70.
Do we know what W actually stood for?
Weights.
Weights, okay.
Year 7s.
So, weights of year 7, okay. So they're normally distributed, that's what we think, we believe, with a mean of 70 kilograms, standard deviation of 7.5. We have taken a sample of size 90, and from that sample, the mean weight of our sample was 71.6 kilograms. And we were testing a null hypothesis that mu was still equal to 70 as always, against an alternative hypothesis that the weight had increased and was now greater than 70, and we were doing it at 5%. So that's a summary of example 1 from before, and I suggest you just write those summary details down now.
For the hypothesis, null hypothesis, and
Yep.
alternative hypothesis, can you just write what you've done there?
Well, properly you would do them in words as well, okay, but just to save time now, because we have already written them out in words in the past when we did them the first time round, I'm just not bothering. Okay. So, that is just a summary there of the question. Now, the new approach is we are going to work out Z. Now, we've come across Z's before when we were doing the normal distribution, and our Z here is going to be x bar minus mu over sigma squared over n square rooted, which is not an unfamiliar thing to us. What was the distribution of Z when we were doing the normal distribution before we even did sampling? What was the distribution of Z? Where will you find Zs? I can see something in front of me that contains lots of Zs. Formula book. Yeah, it's the basic. Z is the normal distribution in the formula book, so which has a mean of 0 and a standard deviation and variance of 1. Okay, and that basically then is what's in the formula book. That's Z. So, for this question, our Z is going to be sample mean 71.6. Take away our assumed population mean 70. Divided by sigma squared, which is 7.5 squared. Divided by the size of our sample, which is 90, and that is going to be square rooted. It is time to reach for your calculators, press buttons in the right order, and tell me a number.
Not wrong. Right.
2.0238.
Yeah, I've got 2.02, okay? So that is our Z number. Now, the whole point of this is, if I sketch a normal curve where I am looking at Z along the bottom, and I have 0 here, because the mean of the Z distribution is 0. This is a one-tailed test I'm doing now, 5% significance level, and I'm interested in, has the weight gone up? So I'm interested in the tail on the right. I'm interested in this 5% over here. Now, from your formula books at the bottom of that page, or possibly even from your memory at this point, because we come across this number a couple of times before, what is the number that goes along the bottom here for a one-tail 5% test? 1.645 is correct. 1.645. If you can't find that, if I just borrow Chelsea's tables a minute, okay? One tail, 95%. There we go, 95%. That's the number you use for a 5% one tail. 1.645. That's where that came from. Okay. Now, how do we decide on what conclusion to accept? Are we accepting H naught or not? We say 2.02. Where is that 2.02 on this Z scale? It's over here. That's where 2.02 is, and it's in the critical region. So 2.02 is in the critical region. And what have we previously done if something is in the critical region? Yeah. So we reject H0 and we accept H1, and then we write down some words, which we're not going to bother doing now because we've already done it when we did example 1 before. Job done.
That's a lot easier.
Yeah. Okay.
Other situations where this doesn't work.
No.
Why did one?
Yeah, why do we learn the null
Because sometimes you will need to. I mean,
that defines like other values?
yeah, sometimes you will need to, and you will need to do that as well for chapter 7, and you will need the approach as well, sometimes for chapter 6. But this is an easier way of doing it. And there are something which I'm a little bit annoyed about in some ways. It isn't in S2, it's not until S3, confidence intervals. And if any of you go on to do in stats at university as well about confidence intervals, then what we did before would be useful as well. But I'm just going to stop the video at that point.